September 12, 1944. The Krupp steel works in Essen, Germany. Oberingenieur Klaus Brenner wiped the sweat from his brow as he studied the intelligence report that had just arrived from the Reich Ministry of Armaments. His hands trembled slightly as he read the impossible statistics typed on official letterhead. American prisoners of war working in converted automobile factories across the United States were producing Sherman tanks at a rate that defied every principle of German engineering philosophy. According to the report, the Chrysler Tank Arsenal in Detroit was completing one M4 Sherman every hour. Every single hour, around the clock, 7 days a week. Brenner had spent his entire career at Krupp, the industrial giant that had forged the backbone of German military might for over a century. He had overseen the production of the mighty Tiger. Tanks, marvels of engineering that required 300,000 man-hours each to complete. The precision manufacturing, the hand-fitted components, the meticulous quality control that made each Tiger a mechanical masterpiece. Yet here, in this damning intelligence summary, was evidence that American prisoners, men who should have been broken by captivity, were somehow building tanks faster than the most experienced armament workers in the Reich. What Brenner couldn't comprehend, what none of the German engineers reading similar reports across the industrial Ruhr Valley could grasp, was that they were witnessing the collision of two fundamentally different philosophies of war production. While Germany pursued perfection through precision, America had weaponized simplicity through standardization. While Krupp craftsmen hand-fitted each component with the dedication of medieval armorers, American assembly lines moved with the relentless rhythm of industrial democracy. The story of how American prisoners of war revolutionized tank production while their captors watched in disbelief begins not in the prison camps of 1944, but in the boardrooms of Detroit in 1940. When the United States entered the war, American automotive executives faced an unprecedented challenge: transform an industry built around consumer comfort into the arsenal of democracy. The solution they devised would prove more revolutionary than any weapon they produced. Knudsen, the Danish immigrant who had transformed General Motors into the world's largest corporation, stood before a gathering of industrialists in Washington, D.C. on December 15, 1941, exactly 8 days after Pearl Harbor. His words would reshape global warfare. "Gentlemen, we're not going to build tanks the way Europeans build tanks. We're going to build them the way Americans build automobiles. Fast, simple, and in numbers that will bury our enemies under an avalanche of steel." The German approach to tank production reflected their military culture. Each panzer was a work of art, engineered to perfection, built to last 1,000 years like everything else in the Reich. The famous Tiger I required components manufactured to tolerances measured in fractions of millimeters. The transmission alone contained 312 precision-machined parts, each one individually tested and fitted. A single Tiger tank consumed resources equivalent to building 42 Volkswagen Beetles. The philosophy was simple: build the best, regardless of cost or time. Meanwhile, in America, automotive engineers were applying mass production principles that Henry Ford had perfected, building the Model T. The Sherman tank, designated M4 by the Army, was designed from the ground up for rapid manufacture. Where German tanks used exotic alloys requiring specialized smelting, the Sherman used standard automotive steel. Where German tanks featured complex interleaved suspension systems with dozens of road wheels, the Sherman used a simple vertical volute spring system borrowed directly from truck design. Where German tanks required specialized tools and gauges for maintenance, the Sherman was designed so any mechanic familiar with automobile engines could service it. The contrast became even more stark when American production ramped up in 1942. The Fisher Body Division of General Motors, which had previously manufactured car bodies, was retooled to produce tank hulls. The transformation took exactly 11 weeks. Workers who had been installing chrome bumpers and leather seats found themselves welding armor plate and mounting cannon. The learning curve was remarkably short, because the fundamental skills translated directly. Precision welding was precision welding, whether joining fenders or armor. But it was the integration of German prisoners of war into American production that created the most profound psychological shock for German leadership. Under the Geneva Convention, prisoners could be employed in non-military industrial work. What the Germans never anticipated was that their own soldiers would become witnesses to American industrial superiority. More than that, they would become participants in their own nation's defeat. The first German prisoners arrived at American industrial facilities in late 1943. These were seasoned veterans, many from Rommel's Afrika Korps, men who understood weapons and machinery. They expected to find primitive American manufacturing, confirmation of Nazi propaganda about American industrial weakness. Instead, they discovered production lines that operated with efficiency that made German precision look positively medieval. At the Chrysler Tank Arsenal, German prisoners worked alongside American women, teenagers, and men too old for military service. They witnessed automated welding systems that joined armor plates faster than the most skilled German craftsmen. They observed quality control procedures that ensured consistency across thousands of vehicles without the hand-fitting that German production required. Most shocking of all, they realized that American inferior mass production was creating tanks that, while less individually perfect than German vehicles, were available in numbers that rendered German quality irrelevant. The psychological impact on German prisoners was documented in intelligence reports that would later surface in Allied archives. Unteroffizier Heinrich Müller, captured at Kasserine Pass and employed at the Ford Willow Run plant, wrote in a censored letter home, "The Americans produce in one day what would take us a month. Their methods seem crude, but the results speak for themselves. They waste nothing because they have everything." The revelation that would forever change German understanding of American industrial capacity began with a single production shift at the Chrysler Tank Arsenal on March 15, 1944. German prisoner Hans Steiner, a former panzer mechanic from the 21st Panzer Division captured in Tunisia, had been assigned to work on the final assembly line. As he watched Sherman after Sherman roll off the production line, each completed in exactly 63 minutes, he began calculating numbers that his German-trained mind refused to accept. Steiner had worked at the MAN factory in Augsburg before the war, where they produced the Panzer IV, Germany's most numerous tank. At MAN, with their most experienced crews working at maximum efficiency, they could complete one Panzer IV every 48 hours. The process required 17 separate quality control inspections, each component tested individually before installation. The transmission took 6 hours to install because each gear required precise adjustment. The turret mounting demanded 4 hours of careful alignment to ensure proper balance and operation. Here in Detroit, Steiner watched American workers, many of them women who had learned their skills just months earlier, install a complete Sherman transmission in 18 minutes. The process was identical for every tank because every transmission was manufactured to such precise standards that no fitting or adjustment was required. Parts were interchangeable not through craftsmanship, but through engineering. The Americans had solved precision not with skilled hands, but with precise machines. The contrast became even more dramatic when Steiner observed American quality control procedures. Where German tanks underwent exhaustive individual testing, American tanks were sample tested using statistical methods. Every 100th tank received complete inspection, while the rest were spot-checked for critical components. The Americans had determined that consistent manufacturing processes eliminated the need for individual verification. They had industrialized quality itself. What truly shocked German prisoners was not just the speed of American production, but the casual efficiency with which it operated. Fritz Heidemann, a captured tank commander from the 15th Panzer Division, working at the Ford Willow Run bomber plant, observed that American workers took regular breaks, worked 8-hour shifts instead of the 12-hour German standard, and yet produced more in their 8 hours than German workers managed in 12. The secret, Heidemann realized, lay in the Americans' understanding of human efficiency. German production pushed workers to exhaustion, believing that maximum effort yielded maximum results. American production recognized that rested workers made fewer mistakes, operated more safely, and maintained higher productivity over longer periods. The Americans had industrialized not just manufacturing, but human resources. German prisoners were also exposed to American material abundance that defied Nazi propaganda. At the Studebaker plant in South Bend, Indiana, where M29 Weasel-tracked vehicles were produced, German POW Otto Braun documented the casual waste that horrified German sensibilities while demonstrating American industrial strength. Sheet steel that contained minor imperfections was discarded and recycled rather than reworked. Components that failed to meet specifications were scrapped without hesitation. Tools were replaced before they showed significant wear rather than maintained until failure. This apparent waste represented a philosophical difference that German prisoners struggled to comprehend. German production conserved materials because resources were scarce. American production optimized time because time was more valuable than materials. When materials were abundant but time was critical, waste became efficiency. The Americans could afford to discard imperfect components because perfect components could be manufactured faster than imperfect ones could be corrected. The shock deepened when German prisoners learned about American production capacity. Werner Kuhn, working at the American Locomotive Company plant in Schenectady, New York, discovered that the single factory where he worked produced more tanks in 1 month than all of Germany's tank plants combined produced in 3 months. The numbers seemed impossible until Kuhn realized that the Americans had built entirely new factories specifically for war production, while Germany was trying to adapt existing facilities. The American approach to industrial expansion revealed another fundamental difference in thinking. German planners viewed existing capacity as fixed and tried to maximize efficiency within those constraints. American planners treated capacity as variable and simply built more factories when more production was needed. The Chrysler Tank Arsenal, completed in just 7 months from groundbreaking to first tank delivery, represented more manufacturing capacity than the entire Krupp organization. German prisoners also witnessed American innovation in real time. At the General Motors diesel division in Cleveland, production methods were continuously improved through worker suggestions and engineering modifications. Changes that would have required months of bureaucratic approval in Germany were implemented within days in America. The Americans treated their production lines as living systems that could evolve and improve, rather than fixed processes that operated according to predetermined specifications. The integration of German prisoners into American production created an intelligence disaster for German leadership. These men returned to prisoner camps with detailed knowledge of American manufacturing capabilities. Their letters home, even when censored, conveyed the overwhelming scale of American production. Their testimonies to newly captured prisoners spread throughout the German military, undermining morale and confidence in ultimate victory. By late 1944, German prisoners had witnessed the production of over 40,000 Sherman tanks, 15,000 aircraft, and countless other vehicles and weapons. They had seen automated production lines, statistical quality control, and industrial processes that exceeded anything in German experience. They had worked alongside American civilians who treated tank production as routine work rather than desperate warfare preparation. Most importantly, they had realized that American industrial superiority was not temporary mobilization, but permanent capability. The psychological impact extended beyond individual prisoners to German leadership. Intelligence reports compiled from prisoner testimonies painted a picture of American production that German planners initially refused to believe. When verification confirmed prisoner accounts, German military leadership faced the stark reality that they were fighting an enemy whose industrial capacity exceeded their own by orders of magnitude. The moment of complete German comprehension came on October 3, 1944, when senior engineer Klaus Brenner received permission to interview German prisoners who had returned from American industrial facilities during a prisoner exchange. What he learned in that sterile interrogation room beneath Krupp headquarters would haunt him for the remainder of the war. Sitting across from Feldwebel Ernst Richter, formerly of the 10th Panzer Division and more recently a worker at the River Rouge Ford complex, Brenner prepared to debunk what he assumed were exaggerated prisoner accounts of American production. Richter had worked for 18 months at River Rouge, witnessing the conversion of automotive production lines to military manufacturing. His technical background as a tank mechanic gave him credibility that previous prisoner reports had lacked. When Brenner asked him to describe American tank production, Richter's response shattered every assumption about industrial warfare that German engineers held sacred. "Mr. Senior Engineer," Richter began, his voice carrying the flat certainty of witnessed truth. "They do not build tanks the way we build tanks. They grow them like crops. I watched a single production line complete 16 Sherman tanks in one 8-hour shift. Not assemble 16 tanks from pre-manufactured components, but complete 16 tanks from raw steel to finished vehicles ready for combat." Brenner interrupted, his engineering training rejecting such impossibilities. "Feldwebel, you must understand the complexity of tank production. The transmission alone requires precision machining of dozens of components. The final drive assemblies demand individual adjustment. The turret mounting necessitates careful alignment. 16 complete tanks in 8 hours would require impossible precision and coordination." Richter smiled grimly. "That is exactly what I thought, Mr. Senior Engineer. I spent my first week looking for the precision, searching for the individual craftsmanship that we know is necessary for proper tank construction. Do you know what I discovered? The Americans had eliminated precision through standardization. Every component was manufactured to such exact specifications that precision became automatic rather than manual. The conversation that followed would be recorded in Krupp archives and later discovered by Allied investigators. Richter described American manufacturing processes that seemed to violate fundamental laws of mechanical production. Components that required hand-fitting in German factories arrived at American assembly lines with tolerances so precise that installation was simply insertion. Quality control that required individual inspection in German plants was achieved through process control that made defects statistically impossible. The Americans, Richter continued, had solved the problem of complex manufacturing by making complexity invisible. Their Sherman tank, which we dismissed as crude compared to our Panthers and Tigers, was actually the most sophisticated piece of mass engineering ever created. Not sophisticated in its individual components, but sophisticated in its producibility. Brenner demanded specific examples, his mind struggling to reconcile prisoner testimony with German engineering experience. Richter provided them with the clinical precision of a technical report. American workers installed Sherman engines in 12 minutes using overhead cranes and precision alignment jigs. German workers required 4 hours to install. Panzer engines, because each installation required individual adjustment, and fitting American transmission installation took 8 minutes because every transmission was identical and every mounting system was standardized. German transmission installation required up to 6 hours, because each transmission required individual alignment and adjustment to compensate for variations in hull. Manufacturing American turret mounting was completed in 6 minutes using automated lifting, equipment and pre-aligned mounting points. German turret mounting required 3 hours because each turret required individual balancing and adjustment to ensure proper rotation and stability. The mathematical implications were staggering. Where German production achieved complexity through craftsmanship, American production achieved simplicity through engineering. The result was not just faster production, but more reliable products. Sherman tanks suffered fewer mechanical failures than German tanks because their standardized components were less prone to the variations that manual fitting introduced. Richter then described something that challenged German assumptions about industrial organization itself. American factories operated with minimal supervision compared to German plants. Workers were expected to identify and solve problems independently rather than refer issues to supervisors. Quality was maintained through process design rather than inspection oversight. Production targets were met through systematic efficiency rather than intensive supervision. They had created, Richter explained, what they called democratic manufacturing. Workers contributed ideas for improvement and were rewarded for innovation. Production methods evolved continuously based on worker input and engineering analysis. The Americans treated their factories as learning organizations rather than fixed systems. This concept of democratic manufacturing violated German hierarchical thinking about industrial organization. In German factories, engineers designed processes, and workers executed them exactly as specified. Innovation came from above, through formal engineering analysis and management decision. The idea that factory floor workers could improve engineering processes seemed chaotic and dangerous to German industrial philosophy. Yet the results spoke for themselves. American factories continuously improved their efficiency, while German factories struggled to maintain established production rates. American workers took ownership of quality problems, while German workers referred problems to supervisors. American production lines adapted to changing requirements, while German production systems required major retooling for modifications. Brenner pressed Richter for information about American worker training, expecting to learn about extensive technical education programs. Instead, he discovered that most American tank production workers received less than 2 weeks of training before beginning work. The Americans had designed their production processes to require skill but not extensive knowledge. Workers learned specific tasks efficiently, rather than comprehensive understanding slowly. This revelation struck at the heart of German craft tradition. German workers underwent years of apprenticeship to develop the skills necessary for precision manufacturing. American workers developed task-specific competence in days or weeks. The Americans had industrialized skill development just as they had industrialized everything else. The conversation concluded with Richter's most damaging testimony. American production was not operating at maximum capacity. The factories he had witnessed could increase output significantly if demand required it. They were producing at sustainable levels that could be maintained indefinitely, rather than crisis levels that would exhaust workers and equipment. German production, by contrast, was already operating beyond sustainable capacity. Workers were exhausted, equipment was wearing out faster than it could be replaced, and quality was declining under pressure to meet impossible quotas. The Americans were fighting a marathon while the Germans were running a sprint, and the marathon was nowhere near finished. The intelligence report that landed on Albert Speer's desk on November 8, 1944, contained information so devastating that the Reich Minister of Armaments initially ordered it classified beyond top secret. The document, compiled from interviews with returned German prisoners and corroborated by captured American technical manuals, revealed production statistics that rendered German war planning obsolete. According to the report, American factories were not just outproducing German facilities, they were redefining the very concept of industrial warfare. Speer had built his reputation on rationalizing German production through centralized planning and efficient resource allocation. Under his leadership, German tank production had tripled from 1942 to 1943. He had achieved what German leaders considered miraculous increases in output through longer working hours, better coordination, and ruthless prioritization. Yet the American production figures in the intelligence report made German achievements appear insignificant. The Chrysler Tank Arsenal alone was producing more Sherman tanks per month than all German factories combined produced of all tank types. The Ford Willow Run plant was completing one B-24 bomber every hour. The Kaiser shipyards were launching Liberty ships faster than German submarines could sink them. Most disturbing of all, these production rates were sustainable indefinitely because they operated within normal working parameters. Rather than crisis mobilization, what made the American achievement even more incomprehensible to German planners was that it had been accomplished largely by workers who had been considered unsuitable for precision manufacturing, women who had never worked in heavy industry, teenagers who lacked industrial experience, elderly men who had been retired from manufacturing, and prisoners of war who should have been demoralized and uncooperative were somehow producing military equipment that exceeded German standards while working at unprecedented speeds. The secret, according to prisoner testimonies, lay in American engineering philosophy that inverted traditional manufacturing logic. Instead of requiring skilled workers to compensate for variable processes, American engineers created invariable processes that allowed unskilled workers to achieve consistent results. Instead of demanding precision from human workers, American systems built precision into mechanical processes that eliminated human variables. Hauptmann Friedrich Weber, a former Panzer officer who had worked at the General Motors Diesel Division in Cleveland, provided Speer's investigators with detailed descriptions of American manufacturing methods that seemed to violate physical laws. American workers installed complete tank engines, including all accessories and connections, in less time than German workers required to remove engines for maintenance. The Americans had achieved this apparent impossibility through what Weber called backwards engineering, instead of designing the best possible tank and then figuring out how to build it. American engineers had designed the most buildable tank that would meet battlefield requirements. Every component was optimized for rapid installation rather than maximum performance. Every system was designed for quick maintenance rather than minimal maintenance requirements. This philosophy extended to the smallest details of American production. German tanks used dozens of different bolt sizes, requiring multiple wrenches and careful inventory control. American tanks used standardized bolts throughout, allowing mechanics to service entire vehicles with minimal tools. German tanks required specific lubricants for different systems. American tanks used universal lubricants that simplified logistics and reduced maintenance complexity. Weber described American quality control procedures that achieved superior results through inferior methods, at least according to German standards. Where German tanks underwent individual testing of every major system, American tanks were batch-tested using statistical sampling. Where German production required master craftsmen to ensure proper assembly, American production used assembly jigs and fixtures that made incorrect assembly impossible. The Americans had solved quality through prevention rather than detection. German quality control found problems after they occurred and corrected them through rework. American quality control prevented problems from occurring through process design that eliminated error possibilities. The result was higher quality at lower cost with faster production. Speer's technical advisors struggled to comprehend American production reports that seemed to contradict established manufacturing principles. German factories achieved higher production through longer working hours and more intensive supervision. American factories achieved higher production through shorter working hours and less supervision. German production maximized output through maximum effort. American production maximized output through systematic efficiency. The philosophical differences extended to factory organization itself. German production followed military principles with clear hierarchies, detailed orders, and strict discipline. Workers were expected to follow instructions precisely without question or variation. Innovation came from engineering departments through formal research and development processes. American production operated according to what prisoners described as industrial democracy. Workers were encouraged to suggest improvements and were rewarded for innovations that increased efficiency or quality. Production methods evolved continuously through worker input and management analysis. The Americans treated their workers as thinking participants, rather than mechanical executors. This democratic approach to manufacturing violated German assumptions about industrial organization and worker capability. German managers believed that workers required detailed supervision to maintain quality and productivity. American managers believed that workers would naturally seek efficiency and quality if given proper tools and incentives. The results validated American assumptions while undermining German practices. American workers took personal responsibility for quality problems and worked cooperatively to solve production challenges. German workers referred problems to supervisors and waited for instructions before taking action. American factories operated as learning organizations that improved continuously. German factories operated as mechanical systems that performed according to predetermined specifications. Speer's most disturbing discovery was that American production superiority was not temporary war mobilization, but permanent industrial capacity. The factories producing Sherman tanks could easily convert to producing civilian automobiles when the war ended. The shipyards building Liberty ships could construct commercial vessels. The aircraft plants manufacturing bombers could build passenger aircraft. German production, by contrast, was specialized for military manufacturing and could not easily convert to civilian purposes. German factories were optimized for current production and could not rapidly adapt to different requirements. German industrial capacity was fixed, while American industrial capacity was flexible. The implications for post-war competition were clear. America would emerge from the war with expanded industrial capacity, improved production methods, and trained workers experienced in advanced manufacturing. Germany would emerge with destroyed factories, obsolete equipment, and exhausted workers. The industrial balance that had taken Germany decades to achieve would be impossible to restore. The transformation of American industrial consciousness began not in the factories, but in the minds of German prisoners who witnessed what they initially dismissed as American mechanical chaos. Obergefreiter Johann Kruger, captured during the Battle of the Bulge and transported to the Buick tank production facility in Flint, Michigan, arrived expecting to find the crude manufacturing methods that Nazi propaganda had promised. Instead, he discovered an industrial ballet that operated with precision he had never imagined possible. Kruger had worked before the war at the Henschel factory in Kassel, where Germany's Tiger tanks were meticulously handcrafted. He understood the intimate relationship between skilled craftsmen and precision machinery that German production required. Each Tiger tank represented months of careful work by master mechanics who had learned their trade through years of apprenticeship. The process was labor-intensive, time-consuming, and produced vehicles of unmatched individual quality. At the Buick facility, Kruger watched American workers who had learned their skills in weeks accomplish tasks that German craftsmen required months to master. The secret was not superior American workers, but superior American systems. Where German production demanded skill from workers, American production embedded skill in processes that made expertise automatic rather than manual. The revelation began on Kruger's first day when he observed the installation of Sherman tank transmission. In Germany, transmission installation required a master mechanic working with 2 assistants for an entire day. The process demanded precise alignment, careful adjustment, and individual fitting to compensate for variations in hull manufacturing. Each installation was unique because each tank was slightly different. At Buick, transmission installation was completed by a single worker in 14 minutes. The worker was a 19-year-old woman named Dorothy Henderson, who had been employed at the plant for exactly 6 weeks. She had never seen a tank before the war began and had learned transmission installation through a training program that lasted 4 days. Henderson's speed and accuracy came not from exceptional skill, but from exceptional systems. The transmission mounting points were machined to tolerances measured in thousandths of an inch. Alignment jigs positioned components automatically. Overhead, cranes handled the heavy lifting with precision that human workers could never achieve. The process was identical for every tank because every component was manufactured to specifications that eliminated variation. Kruger realized that the Americans had solved the problem of complex manufacturing through simplification rather than sophistication. German production achieved precision through skilled workers compensating for imprecise processes. American production achieved precision through precise processes that eliminated the need for skilled compensation. The contrast became even more dramatic when Kruger observed American quality control procedures. German tanks underwent exhaustive individual testing because variations in handcrafted components required verification of each vehicle's performance. American tanks were sample tested because standardized manufacturing made individual testing redundant. The Americans had industrialized quality through consistency rather than inspection. Kruger, documented his observations in letters that passed military censors, because his technical descriptions seemed too incredible to constitute useful intelligence. He described American workers operating with casual efficiency that produced results exceeding German maximum effort. He witnessed production schedules maintained without the intensive supervision that German factories required. He observed quality standards achieved through systematic processes rather than individual craftsmanship. The psychological impact on German prisoners extended beyond admiration for American efficiency to questioning of German industrial philosophy. Unteroffizier Hans Müller, working at the Pressed Steel Car Company in Pittsburgh, began to understand that German and American approaches to manufacturing represented fundamentally different worldviews about human capability and industrial organization. German production assumed that quality required constant vigilance, intensive supervision, and skilled intervention. Workers were potential sources of error who needed detailed instruction and continuous oversight. Quality was achieved through detection and correction of problems after they occurred. American production assumed that quality could be built into systems that made errors impossible rather than unlikely. Workers were potential sources of innovation who could contribute to continuous improvement. Quality was achieved through prevention of problems before they occurred. These philosophical differences produced practical results that German prisoners witnessed daily. American factories operated with lower supervisory ratios while maintaining higher quality standards. American workers took responsibility for production problems, while German workers waited for supervisory direction. American production systems adapted continuously, while German systems operated according to fixed specifications. Mueller's most shocking discovery was that American workers were encouraged to stop production when they identified problems rather than continue working, and hoped supervisors would notice issues later. In German factories, stopping production without explicit authorization was grounds for severe discipline. In American factories, failing to stop production when problems were identified was considered irresponsible. This inversion of industrial authority reflected deeper differences in American and German assumptions about worker intelligence and responsibility. German industrial culture treated workers as disciplined executors of engineering decisions. American industrial culture treated workers as thinking participants in engineering processes. The results validated American assumptions while challenging German practices. American factories achieved higher productivity through worker engagement rather than worker compliance. American quality improved through worker initiative rather than supervisory control. American innovation emerged from production floors rather than engineering departments. German prisoners also witnessed American material abundance that rendered German resource conservation practices obsolete. At the Baldwin Locomotive Works in Philadelphia, Gefreiter Otto Schneider observed American workers discarding materials that German workers would have carefully salvaged and reused. Sheet steel with minor surface imperfections was scrapped rather than reworked. Components that failed dimensional inspection were recycled rather than adjusted. This apparent waste represented abundance thinking that German scarcity experience could not comprehend. German production conserved materials because alternatives were unavailable. American production optimized time because materials were replaceable, but schedules were critical. The Americans could afford material waste because they could not afford time waste. Schneider gradually understood that American industrial strength lay not in superior resources, but in superior resource utilization. German factories hoarded materials, while American factories consumed materials efficiently. German production minimized waste through careful conservation. American production minimized waste through rapid consumption that eliminated storage, handling, and inventory costs. The cumulative testimony of German prisoners created an intelligence picture that German leadership found impossible to accept. American industrial capacity exceeded German estimates by factors that seemed mathematically impossible. American production methods achieved results that violated German engineering assumptions. American workers demonstrated capabilities that contradicted German racial theories about American industrial competence. The moment that German industrial Confidence finally shattered came on December 15, 1944, when Reichsminister Albert Speer convened an emergency meeting of Germany's top production engineers to analyze what he called the American industrial phenomenon. In attendance were the most brilliant minds of German manufacturing, directors from Krupp, Henschel, MAN, and Daimler-Benz. These men had built the industrial backbone of the Reich, had overseen the production of Germany's most sophisticated weapons, and had believed themselves the masters of modern manufacturing. What they learned in that meeting would haunt them through Germany's final collapse and beyond. The intelligence reports compiled from prisoner testimonies, captured documents, and aerial reconnaissance painted a picture of American production that rendered German achievements obsolete, not just inferior, but belonging to an entirely different era of industrial thinking. Dr. Ferdinand Porsche, whose company had designed the Tiger tank and countless other German military vehicles, sat in stunned silence as Speer read production statistics that seemed to mock decades of German engineering achievement. The single Ford River Rouge complex employed more workers than all of Germany's tank production facilities combined. The Willow Run bomber plant produced more aircraft in 1 month than German factories managed in 6 months. The Kaiser shipyards launched vessels faster than German intelligence could count them. "Gentlemen," Speer announced to the assembled engineers, "we are not merely losing a production race. We are discovering that we never understood what production could become." The American approach to manufacturing had evolved beyond German comprehension through principles that violated traditional European industrial wisdom. Where German production pursued perfection through precision craftsmanship, American production achieved adequacy through systematic standardization. Where German factories emphasized individual excellence, American factories emphasized collective efficiency. Dr. Heinrich Nordhoff from Volkswagen, who would later become famous for rebuilding the company after the war, struggled to comprehend prisoner reports describing American production methods. German workers at Volkswagen required extensive training to master the precise hand-fitting that their manufacturing processes demanded. American workers at Sherman tank plants became productive after training, programs that lasted less than 2 weeks. Americans had eliminated the skilled craftsmanship that German production considered essential through engineering systems that made craftsmanship unnecessary. Instead of requiring workers to compensate for manufacturing variations, American engineers designed manufacturing processes that eliminated variation. Instead of demanding precision from human hands, American systems built precision into mechanical processes. Oberingenieur Wilhelm Maybach, whose engines powered German tanks and aircraft, reviewed technical specifications captured from American factories with growing dismay. American engines used standardized components throughout their production lines. A single bolt design appeared in dozens of different applications. A standard bearing size fit multiple different systems. Universal fasteners eliminated the need for specialized tools. German engines, by contrast, used optimized components for each specific application. Every system had individually designed elements that maximized performance for particular requirements. The result was superior individual performance at the cost of manufacturing complexity, maintenance difficulty, and logistical complications. American standardization sacrificed theoretical perfection for practical superiority. Their tanks might not achieve the absolute performance of individually optimized German vehicles, but they could be produced in numbers that made individual superiority irrelevant. More importantly, they could be maintained and repaired by any mechanic with basic training using standard tools and universal parts. The meeting's most disturbing revelation came when Speer presented intelligence about American production capacity utilization. German factories were operating at maximum theoretical capacity, with workers logging 12-hour shifts and equipment running continuously. Any increase in production required building new facilities or finding more workers, both of which were impossible given wartime resource constraints. American factories were operating at comfortable, sustainable levels that could be increased significantly if demand required it. They were producing enough to overwhelm German production while maintaining reserves for further expansion. The Americans were fighting an industrial war while Germany was fighting an industrial emergency. Professor Ernst Heinkel, whose aircraft company had produced some of Germany's most advanced fighters, listened to reports of American aircraft production with growing horror. The Americans were not just building more aircraft. They were building aircraft faster than German pilots could be trained to fly them. American pilot training programs were graduating more aviators monthly than Germany had trained in the entire war. The implications extended beyond current production to post-war industrial competition. American factories would emerge from the war with expanded capacity, improved methods, and experienced workers. German factories would emerge as rubble. American engineering would advance through wartime innovation and mass production experience. German engineering would be scattered, suppressed, and obsolete. Speer's final presentation addressed the psychological dimension of American industrial superiority. German prisoners working in American factories had witnessed not just superior production methods, but superior industrial culture. American workers contributed ideas for improvement and were rewarded for innovation. Production problems were solved cooperatively rather than hierarchically. Quality was maintained through worker pride rather than supervisory fear. We have discovered, Speer concluded, that the Americans have democratized excellence. They have created systems that allow ordinary people to produce extraordinary results. We have pursued excellence through extraordinary people producing expected results. Their approach scales infinitely. Ours reaches natural limits. The assembled engineers sat in silence as the implications settled over them. German industrial philosophy emphasized elite performance by exceptional individuals. American industrial philosophy emphasized systematic performance by typical individuals. In a total war requiring massive production, systematic performance by millions defeated elite performance by thousands. The meeting ended with an admission that none of the participants would have believed possible 6 months earlier. German industry, despite its reputation for precision and quality, had been comprehensively surpassed by American methods that emphasized speed and quantity. The craftsmanship tradition that Germans considered their greatest strength had become their critical weakness in industrial warfare. Dr. Porsche's closing comment captured the mood of German industrial leadership. We have spent decades perfecting the art of building beautiful machines slowly. The Americans have spent years perfecting the science of building adequate machines quickly. In war, adequate machines available immediately. Defeat beautiful machines available eventually. The intelligence, reports that had triggered the meeting, would be buried in German archives as too demoralizing for general circulation. But the knowledge contained in those reports had already spread through German prisoner testimonies, undermining confidence in ultimate victory and accelerating the psychological collapse that would precede Germany's military defeat. The industrial awakening that would reshape global manufacturing began in the most unlikely place, the cramped barracks of German prisoner of war camps scattered across the American Midwest. As winter deepened in early 1945, thousands of German soldiers who had witnessed American production firsthand found themselves serving as unwitting evangelists for a manufacturing revolution that their own leaders could barely comprehend. Among these reluctant witnesses was Feldwebel Gustav Hermann, a veteran tank mechanic from the 116th Panzer Division who had been captured during the Battle of the Bulge. Hermann possessed the technical expertise to understand what he had observed during 8 months at the General Motors tank automotive plant in Grand Blanc, Michigan. More importantly, he possessed the credibility to convince skeptical fellow prisoners that his testimony was accurate rather than exaggerated. In the cold Indiana barracks of Camp Atterbury, Hermann addressed a gathering of recently captured German officers who still believed Nazi propaganda about American industrial weakness. His words would shatter their illusions about German technological superiority and reveal the true scope of American manufacturing achievement. Kameraden, Hermann began, his voice carrying the authority of witnessed truth. Everything we believed about American production was wrong. Not merely incomplete or outdated, but fundamentally, catastrophically wrong. I have watched American workers, many of them women and teenagers, produce tanks faster and better than our most experienced Krupp technicians. The assembled officers shifted uncomfortably. These were men who had been raised on stories of German engineering excellence, who had witnessed the precision of German manufacturing, who had operated the sophisticated machinery that German industry produced. The suggestion that Americans could exceed German production seemed to violate natural law. Hermann continued with clinical precision, describing production methods that seemed to invert established manufacturing principles. At General Motors, I observed the installation of complete tank powertrains in 17 minutes. Not the engine alone, but the entire drivetrain, including transmission, final drives, and all connecting systems. The same installation that requires our technicians 4 hours to complete. Oberst Wilhelm Bauer, formerly commanding officer of a Panzer regiment, interrupted with the skepticism that German officers had been trained to display toward impossible claims. Feldwebel, you must understand that proper powertrain installation requires precise alignment, careful adjustment, and individual fitting. 17 minutes would be insufficient for basic positioning, much less complete installation and testing. Hermann's response would be repeated in prisoner camps throughout America as captured German soldiers struggled to convey observations that challenged fundamental assumptions about industrial capability. Oberst. That is exactly what I believed before I witnessed American methods. They have eliminated the precision alignment through manufacturing tolerances so exact that alignment becomes automatic. They have eliminated the careful adjustment through standardization so complete that adjustment becomes unnecessary. They have eliminated the individual fitting through engineering so sophisticated that fitting becomes universal. The conversation that followed revealed the philosophical chasm between German and American approaches to complex manufacturing. German production achieved precision through skilled human intervention compensating for variable processes. American production achieved precision through invariable processes that eliminated the need for human compensation. Hermann described American quality control procedures that maintained superior standards through methods that seemed to violate German engineering logic. Where German tanks required individual testing of each major system, American tanks achieved quality through process control that made defects statistically impossible. Where German production emphasized detection and correction of problems, American production emphasized prevention of problems through system design. The Americans had solved manufacturing complexity not through more sophisticated craftsmanship, but through more sophisticated engineering that made craftsmanship unnecessary. They had industrialized precision itself, creating mechanical systems that achieved accuracy automatically rather than manually. Major Franz Kellner, a former Panzer maintenance officer, demanded specific technical details that would either verify or disprove Hermann's claim. Hermann provided them with the exhaustive precision that his mechanical background enabled. American tank transmissions were manufactured to tolerances of plus or minus 0.02 of an inch across all dimensions. German transmissions required hand fitting to compensate for variations that could exceed 0.10 of an inch. American engine blocks were machined using automated equipment that maintained dimensional accuracy within 1/1000 of an inch. Throughout production runs of thousands of units, German engine blocks were individually machined and required skilled machinists to achieve similar precision on each separate unit. American assembly lines used positioning jigs and fixtures that made incorrect installation impossible rather than unlikely. German assembly procedures relied on worker skill and inspection to prevent installation errors that mechanical systems could not prevent. The cumulative effect of these technical advantages was production capability that exceeded German achievements by factors that seemed mathematically impossible. Hermann's calculations, verified by other German prisoners with technical backgrounds, indicated that American tank production exceeded German output by ratios approaching 10 to 1 when all factors were Considered more disturbing than current production statistics were American capacity, reserves that promised even greater future output. German factories were operating at maximum theoretical capacity with no possibility of significant expansion. American factories were operating at sustainable levels that could be increased substantially if demand required greater production. Hermann's testimony revealed that American industrial superiority was not temporary war mobilization but permanent capability that would persist after military victory. The factories producing Sherman tanks could easily convert to civilian automobile production. The shipyards building Liberty ships could construct commercial vessels. The aircraft plants manufacturing bombers could build passenger aircraft. German production, by contrast, was specialized for military manufacturing and could not readily adapt to peacetime requirements. German industrial capacity was optimized for current production and could not rapidly modify for different products. The Americans had built flexibility into their manufacturing systems while Germans had built efficiency into fixed processes. The implications for post-war economic competition were clear to German officers who understood industrial economics. America would emerge from the war with expanded production capacity, advanced manufacturing methods, and trained workers experienced in sophisticated production techniques. Germany would emerge with destroyed factories, obsolete equipment, and scattered technical expertise. The prisoner camp discussions that Hermann's testimony initiated spread throughout the German POW population in America. Technical personnel who had witnessed American production shared observations that painted a consistent picture of manufacturing capability that exceeded German achievements across all categories of production. These discussions had psychological effects that extended beyond industrial admiration to fundamental questioning of German assumptions about national capability and racial superiority. If Americans could achieve manufacturing excellence that surpassed German performance, what other assumptions about American inferiority required reconsideration? The industrial revelation that would haunt German consciousness for generations crystallized on February 22, 1945, when captured documents from the Ford River Rouge complex reached the desk of Dr. Fritz Toth's successor at the Reich Ministry of Armaments. The documents, seized during a failed German commando raid on American industrial facilities, contained production schedules and capacity assessments that rendered German war planning obsolete. What German intelligence discovered was not merely American industrial superiority, but American industrial philosophy that had evolved beyond European comprehension. The River Rouge complex employed 120,000 workers, producing military vehicles, aircraft engines, and components for dozens of different weapons systems. The single facility consumed more steel monthly than all of Germany's remaining tank factories combined. More significantly, River Rouge was operating at 70% of theoretical capacity while maintaining production schedules that exceeded German maximum effort outputs. German prisoners working at River Rouge had witnessed production methods that seemed to violate physical laws of manufacturing complexity. Dr. Wolfgang Steiner, a captured engineer from the Porsche Design Bureau, had spent 6 months observing American production techniques while officially employed as a technical translator. His secret reports, smuggled through Red Cross channels, provided German leadership with detailed analyses of American manufacturing philosophy. Steiner's most devastating observation concerned American attitudes toward production optimization. German factories pursued maximum efficiency through intensive utilization of existing equipment and facilities. American factories pursued maximum productivity through systematic replacement of equipment and continuous improvement of facilities. The Americans treated their production systems as evolutionary, organisms that could adapt and improve, rather than mechanical systems that operated according to fixed specifications. This evolutionary approach to manufacturing yielded results that German static optimization could never achieve. American production lines continuously increased output through worker suggestions, engineering modifications, and equipment upgrades. German production lines operated at predetermined efficiency levels that could only be changed through major Retooling or facility reconstruction. The captured documents revealed that American factories were redesigning their production processes monthly based on operational experience and worker feedback. Changes that would require 6 months of bureaucratic approval in German facilities were implemented within days in American plants. The Americans had created learning organizations that improved automatically rather than administrative organizations that changed. Reluctantly, Steiner's technical analysis identified specific American innovations that had revolutionized manufacturing efficiency. Overhead, conveyor systems moved components automatically between workstations, eliminating the manual handling that German production required. Specialized jigs and fixtures positioned components precisely for assembly, reducing the skilled alignment that German workers provided manually. Quality control instrumentation detected defects immediately, rather than requiring post-production inspection that German methods used. The Americans had mechanized not just production, but the intelligence that production required. Where German manufacturing relied on human judgment and skill to compensate for system limitations, American manufacturing embedded judgment and skill in mechanical systems that performed consistently without human variable. Perhaps most shocking to German observers was American waste tolerance that actually increased overall efficiency. German production conserved materials through careful utilization and extensive rework of defective components. American production discarded imperfect materials and components rather than invest time in correction. The Americans had calculated that material waste was less expensive than time waste when materials were abundant and schedules were critical. This abundance thinking reflected resource availability that German scarcity experience could not comprehend. American factories consumed materials with casual efficiency that would have horrified German production managers. Steel sheets with minor surface imperfections were scrapped and recycled. Machined components that failed dimensional inspection were discarded rather than reworked. Tools were replaced before showing significant wear rather than maintained until failure. Yet this apparent waste produced superior results through systematic efficiency that compensated for material consumption. American factories achieved higher quality through prevention rather than correction. American workers maintained higher productivity through optimal tools rather than maximal utilization. American production sustained higher output through equipment reliability rather than equipment endurance. The captured documents also revealed American planning horizons that extended far beyond immediate military requirements. Production facilities were designed for post-war conversion to civilian manufacturing. Worker training programs prepared personnel for peacetime employment in expanded industries. Research and development efforts addressed long-term technological advancement rather than immediate battlefield needs. German planning, by contrast, focused entirely on short-term military production with no consideration of post-war industrial requirements. German factories were optimized for current weapons production and could not easily adapt to different products. German worker training emphasized specific military manufacturing skills that would be obsolete in peacetime. German research concentrated on immediate tactical advantages rather than strategic technological development. The Americans were simultaneously fighting the current war and preparing for the post-war economy. Their industrial mobilization strengthened rather than weakened their long-term economic position. German industrial mobilization was consuming the foundation of future economic capability while failing to match American current production. Steiner's most disturbing revelation concerned American production scalability. The manufacturing methods he had observed could be replicated indefinitely given sufficient resources and demand. American factories were not unique facilities operated by exceptional personnel, but standard installations using systematic processes that could be duplicated anywhere with appropriate training and equipment. German production, by contrast, depended on accumulated expertise and specialized facilities that could not be quickly replicated. German manufacturing excellence was concentrated in specific locations with particular workers who had developed skills through years of experience. American manufacturing excellence was distributed through standardized systems that could be implemented by typical workers following established procedures. This scalability difference had profound implications for global industrial competition. American manufacturing methods could be exported to allied nations, licensed to foreign companies, or replicated in new facilities anywhere in the world. German manufacturing methods were tied to specific industrial cultures and skilled populations that could not be easily transferred or duplicated. The captured documents painted a picture of American industrial capacity that rendered German resistance futile from purely mathematical perspectives. American production exceeded German output by margins that military strategy could not overcome. American reserves exceeded German maximum effort by factors that battlefield tactics could not compensate. American industrial growth was accelerating while German production was declining. More fundamentally, the documents revealed that American industrial philosophy represented an evolutionary advance in manufacturing thinking that made German approaches obsolete. The Americans had solved problems that German engineering had not recognized as solvable. They had achieved capabilities that German industry had considered theoretically impossible. They had created manufacturing systems that operated beyond German conceptual frameworks. The psychological breaking point for German industrial leadership arrived on March 10, 1945, when a secret intelligence summary reached the inner circle of Nazi command. The document, compiled from multiple sources, including prisoner testimonials, captured equipment specifications, and aerial reconnaissance photographs, contained a single statistic that rendered German war production efforts meaningless. American factories were producing more military equipment while operating at reduced capacity than German factories could manufacture at maximum theoretical output. Reichsmarschall Hermann Göring, whose Luftwaffe had been systematically destroyed by American industrial output, read the intelligence report in his opulent study at Karen Hall. The man who had once boasted that no Allied bomber would ever reach. Berlin was confronted with evidence that American aircraft production exceeded German output by ratios that made strategic defense impossible. The United States was building aircraft faster than Germany could train pilots to fly them, even if German aircraft production had been unlimited. The report detailed observations by Oberst Heinrich Weber, a captured Luftwaffe engineering officer, who had been assigned to work at the Consolidated Aircraft Plant in San Diego. Weber possessed the technical expertise to understand American aircraft manufacturing and the military experience to assess its strategic implications. His testimony shattered German assumptions about industrial warfare and revealed the true scope of American productive capacity. Weber had witnessed the production of B-24 Liberator bombers using assembly methods that seemed to violate aeronautical engineering principles. German aircraft were handcrafted by skilled technicians who fitted each component individually to ensure proper aerodynamic performance. American aircraft were assembled using interchangeable components manufactured to tolerances so precise that individual fitting became unnecessary. The Consolidated Plant completed one B-24 bomber every hour using workers who had learned aircraft. Assembly and training programs lasting less than 3 weeks. German aircraft plants required 3 months to complete similar bombers using craftsmen who had trained for years to develop necessary skills. The Americans had eliminated craftsmanship through engineering that made precision automatic rather than manual. Weber's technical analysis revealed American innovations that had revolutionized aircraft manufacturing. Wing assemblies were manufactured using interchangeable ribs, spars, and skin panels that assembled identically regardless of which specific components were used. German wings required individual fitting and adjustment because component variations demanded skilled compensation. American engines were installed as complete power plants, including all accessories and connections. German engines were installed as separate components that required individual fitting and connection by skilled mechanics. American landing gear systems used standardized components that installed identically in every aircraft. German landing gear required individual adjustment and alignment for each installation. The cumulative effect of these technical advantages was production capability that exceeded German achievements by factors that seemed impossible. Weber calculated that the single consolidated plant where he worked produced more heavy bombers monthly than all German aircraft factories combined produced in 6 months. More disturbing than current production statistics were American capacity reserves that promised unlimited future expansion. The consolidated plant was operating 2 8-hour shifts with normal industrial scheduling. The facility could easily operate 3 shifts continuously if demand required increased production. Additional production lines could be added to existing. Buildings or new facilities could be constructed if even greater output was needed. German aircraft production was already operating at absolute maximum capacity, with workers logging 12-hour shifts and equipment running continuously. Any increase in production required building new facilities or finding more workers, both impossible given wartime resource constraints. German production had reached natural limits, while American production was operating within comfortable margins. Weber's observations extended beyond aircraft manufacturing to American industrial culture that enabled superior productivity through methods that German management considered impossible. American workers were encouraged to suggest improvements and were rewarded for innovations that increased efficiency. Production problems were solved cooperatively between workers and supervisors rather than hierarchically through management decisions. This democratic approach to manufacturing yielded continuous improvements that German authoritarian methods could not achieve. American production lines evolved daily through worker input and engineering analysis. German production systems operated according to fixed specifications that could only be changed through formal redesign processes. Weber witnessed American material abundance that rendered German conservation practices obsolete while demonstrating industrial capacity that exceeded German comprehension. Aluminum sheets with minor surface imperfections were discarded and recycled rather than reworked. Electronic components that failed testing were scrapped rather than repaired. Tools were replaced based on schedules rather than wear indicators. This apparent waste reflected abundance thinking that German scarcity experience could not understand. American production optimized time rather than materials because materials were replaceable while schedules were critical. German production optimized materials rather than time because materials were scarce while schedules were flexible. TAHIU intelligence report concluded with strategic assessments that rendered German military planning obsolete. American aircraft production was increasing monthly, while German production was declining. American pilot training was graduating more aviators weekly than Germany trained monthly. American aircraft design was advancing through continuous innovation, while German design was stagnating through resource limitations. More fundamentally, American industrial capacity represented permanent capability that would persist after military victory. The factories producing military aircraft could convert to civilian aviation manufacturing. The workers trained in aircraft assembly could apply their skills to peacetime production. The engineering advances developed for military applications could enhance commercial aircraft development. German aircraft industry would emerge from the war as bombed ruins with scattered personnel and obsolete equipment. American aircraft industry would emerge with expanded facilities, advanced methods, and experienced workers positioned to dominate global aviation markets for decades. Göring's response to the intelligence report was recorded by his adjutant and later discovered in captured German archives. "We are not losing an air war," the Reichsmarshal stated with the clarity that approaching defeat sometimes provides. "We are being buried under an avalanche of American production that renders our tactical superiority meaningless. They are not defeating our aircraft with better aircraft. They are defeating our dozens with their thousands." The psychological impact of American industrial superiority extended throughout German leadership as similar intelligence. Reports arrived from every theater of war: tank production, naval construction, small arms manufacturing, and artillery production all told the same story of American capacity that exceeded German achievement by margins that military strategy could not overcome. The final collapse of German industrial confidence occurred on April 3, 1945, in the bombed-out ruins of the Krupp steelworks in Essen, where Oberingenieur Klaus Brenner stood amid the twisted wreckage of what had once been Germany's greatest industrial complex. In his hands, he held the last intelligence report he would ever receive about American production capabilities. The document, compiled from the final testimonies of German prisoners returning from American factories, contained revelations that made Germany's industrial defeat complete and irreversible. The report detailed observations by Hauptmann Georg Richter, a former tank commander who had spent 18 months working at the American Locomotive Company plant in Schenectady, New York. Richter possessed both the technical knowledge to understand complex manufacturing and the military experience to assess strategic implications. His testimony provided the final pieces of a puzzle that revealed the true scope of American industrial achievement. Richter had witnessed the production of M26 Pershing tanks using manufacturing methods that represented the culmination of American industrial evolution. The Americans had not merely improved upon German production techniques, they had transcended traditional manufacturing limitations through systematic innovation that eliminated every constraint that limited German output. The Schenectady plant produced heavy tanks, using assembly methods that seemed to violate mechanical engineering principles. German tanks required individual fitting and adjustment of major components because manufacturing tolerances demanded skilled compensation. American tanks used components manufactured to specifications, so precise that assembly became mechanical insertion rather than skilled installation. Richter calculated that American manufacturing tolerances were consistently 5 times more precise than German standards. Across all major components, engine blocks were machined to dimensional accuracies that German equipment could not achieve. Transmission housings were manufactured with surface finishes that German processes could not duplicate. Turret rings were ground to circular tolerances that German methods could not maintain. This precision manufacturing was achieved not through superior craftsmanship, but through superior machinery operated by workers whose skill requirements were actually lower than German standards. American machine tools maintained dimensional accuracy automatically through mechanical feedback systems that eliminated human variables. German machine tools required skilled operators to compensate for mechanical limitations through manual adjustment and constant measurement. The Americans had solved manufacturing precision through engineering rather than skill, creating production systems that achieved superior results with inferior human requirements. They had democratized excellence by building capability into machines rather than demanding capability from workers. Richter's most shocking discovery concerned American production scheduling that operated with efficiency margins impossible under German methods. The Schenectady plant maintained production targets while allowing workers regular breaks, limiting shifts to 8 hours, and providing time for equipment maintenance and facility cleaning. German production achieved lower output despite 12-hour shifts, minimal breaks, and deferred maintenance that frequently caused equipment failure. American scheduling recognized that sustained productivity required sustainable working conditions. German scheduling assumed that maximum effort produced maximum results regardless of human and mechanical limits. The American approach yielded higher long-term output, while the German approach caused declining productivity through workers' exhaustion and equipment deterioration. The intelligence report documented American innovations that had eliminated every production bottleneck that constrained German manufacturing. Material handling used automated conveyor systems that moved components between workstations without manual labor. Component positioning employed mechanical jigs and fixtures that eliminated skilled alignment requirements. Quality control utilized statistical sampling that maintained standards without individual inspection. More significantly, American production had achieved complete integration between design and manufacturing that eliminated the coordination problems plaguing German industry. Engineering drawings specified not just component dimensions, but assembly procedures that optimized production efficiency. Manufacturing methods influenced design decisions to ensure that products could be built, rapidly using available equipment and skills. German production maintained separation between design and manufacturing that created coordination. difficulties and production inefficiencies. Engineers designed optimal products without adequate consideration of manufacturing limitations. Production personnel struggled to build products that had not been designed for efficient manufacture. Richter's testimony revealed American quality control philosophy that achieved superior results through prevention rather than detection. German quality control identified problems after they occurred and corrected them through rework that consumed time and materials. American quality control prevented problems from occurring through process design that made defects impossible rather than improbable. American manufacturing systems included automatic feedback, mechanisms that detected deviations from specifications immediately and corrected them before defective products were produced. German manufacturing systems relied on post-production inspection that identified problems after resources had been consumed producing defective items. The Americans had created learning production systems that improved continuously through operational experience. Problems were analyzed systematically to identify root causes that could be eliminated through process modifications. Improvements were implemented rapidly and distributed throughout production networks to prevent similar problems at other facilities. German production systems operated according to fixed procedures that could only be changed through formal engineering, reviews, and management approvals. Problems were addressed through corrective actions that treated symptoms rather than causes. Improvements were implemented slowly and often failed to spread beyond specific locations where they were developed. The intelligence report concluded with strategic assessments that rendered German resistance meaningless from industrial perspective. American production capacity was accelerating through continuous improvement, while German capacity was declining through resource exhaustion and facility destruction. American industrial methods were advancing through innovation, while German methods were stagnating through isolation and material shortages. Most fundamentally, American industrial philosophy represented permanent advancement in manufacturing capability that would dominate global production for generations. The systematic methods, precision equipment, and trained personnel that American factories had developed would provide competitive advantages that traditional industrial nations could not match without completely restructuring their manufacturing approaches. Brenner folded the intelligence report and placed it in his briefcase as Allied artillery shells exploded in the distance. Around him, the ruins of Krupp bore testimony to German industrial achievement that had once been the envy of the world. The great forges were silent, their furnaces cold, their machinery twisted into abstract sculptures of defeat. In his final log entry, discovered after the war in Krupp archives, Brenner wrote, "We believed that German precision and craftsmanship represented the pinnacle of industrial achievement. We discovered that American systematization and standardization had transcended traditional manufacturing limitations. We pursued excellence through individual skill. They achieved excellence through systematic capability. We built beautiful machines slowly. They built adequate machines quickly. In total war, adequate machines available immediately defeat beautiful machines available eventually." The industrial reckoning that would reshape global manufacturing forever reached its crescendo on April 18, 1945, when the last German prisoners returning from American factories arrived at Stalag Sissevendier near Moosburg. Among them was Obergefreiter Wilhelm Hartmann, a master machinist from the Maybach Engine Works who had spent 2 years observing American production methods at the Ford Rouge River complex. His testimony to fellow prisoners would serve as the final chapter in Germany's industrial awakening to American superiority. Hartmann possessed the technical expertise that few German soldiers could claim. Before the war, he had been responsible for precision machining of engine components that powered German tanks and aircraft. His craftsmanship had been legendary. At Maybach, where his ability to machine components to tolerances measured in fractions of thousandths of inches had earned him the respect of engineers and supervisors. He understood manufacturing precision as few men could, making his observations about American production particularly credible and devastating. At the Rouge complex, Hartmann had witnessed manufacturing methods that challenged every assumption. about precision machining that his German training had instilled. American machinists produced engine components using automated equipment that maintained dimensional accuracy superior to anything he could achieve through manual skill. More shocking still, these American machinists required less training and possessed fewer traditional skills than German apprentices, yet consistently produced superior results. The secret lay not in superior American workers, but in superior American systems that embedded precision in mechanical processes rather than human capabilities. Where German machining required skilled operators to compensate for equipment limitations, through manual adjustment and constant measurement, American machining used automated feedback systems that maintained accuracy without human intervention. Hartmann described American machine tools that seemed to operate beyond physical limitations that constrained German equipment. Automated lathes maintained cutting speeds and feed rates with consistency that manual operation could never achieve. Milling machines held dimensional tolerances across production runs of thousands of components, without the gradual deterioration that German equipment experienced. Grinding machines produced surface finishes that exceeded German capabilities, while operating at speeds that German methods could not sustain. The Americans had solved manufacturing precision through engineering rather than craftsmanship, creating production systems that achieved superior results with minimal human skill requirements. They had industrialized precision itself, making accuracy automatic rather than manual. More disturbing to German prisoners was Hartmann's testimony about American production capacity that operated with reserves impossible under German methods. The Rouge complex could increase output substantially if demand required greater production. Additional shifts could be added, production lines could be accelerated, and parallel manufacturing operations could be established without significant facility modifications. German production was already operating at absolute maximum capacity with no possibility of meaningful expansion. Workers were laboring 12-hour shifts with minimal breaks. Equipment was running continuously without scheduled maintenance. Facilities were utilized beyond design specifications in desperate attempts to increase output. The Americans were fighting an industrial war while maintaining industrial sustainability. Germans were fighting an industrial emergency that was consuming the foundation of future productive capability. Hartmann's most shocking revelation concerned American waste tolerance that actually enhanced overall efficiency through systematic optimization. American production discarded materials and components that German conservation practices would have salvaged and reworked. Steel billets with minor surface imperfections were recycled rather than machined to remove flaws. Machined components that failed dimensional inspection were scrapped rather than reworked to achieve specifications. This apparent waste reflected abundance thinking that German scarcity experience could not comprehend. American production optimized total efficiency rather than material utilization because materials were replaceable while time was irreplaceable. German production optimized material conservation rather than time efficiency because materials were scarce while time seemed unlimited. Yet American waste produced superior results through systematic efficiency that more than compensated for material consumption. Discarding imperfect materials eliminated the time required for rework. Scrapping failed components prevented quality problems that rework might not completely resolve. Replacing worn tools before failure eliminated production delays that tool failure would cause. The Americans had calculated that material waste was less expensive than time waste when materials were abundant and schedules were critical. German production had never faced abundance sufficient to make such calculations meaningful, creating psychological barriers to understanding American methods. Hartmann's testimony revealed American production planning that extended beyond immediate military requirements to post-war industrial competition. Manufacturing equipment was selected not just for current production efficiency, but for adaptability to peacetime manufacturing. Worker training emphasized general industrial skills rather than specific military production techniques. Research and development addressed long-term technological advancement rather than immediate battlefield application. German production focused entirely on immediate military needs without consideration of post-war requirements. Equipment was optimized for current weapons production and could not easily adapt to different products. Worker training emphasized specific military manufacturing skills that would be obsolete in peacetime. Research concentrated on immediate, tactical advantages rather than strategic technological development. The Americans were simultaneously fighting the current war and preparing for post-war economic dominance. Their industrial mobilization strengthened rather than weakened their long-term competitive position. German industrial mobilization was consuming future capability while failing to match American current output. Perhaps most devastating to German morale was Hartmann's description of American worker attitudes that achieved superior productivity through methods German management considered impossible. American workers took personal responsibility for quality problems and worked cooperatively to solve production challenges. They contributed suggestions for improvement and were rewarded for innovations that increased efficiency. German workers referred problems to supervisors and waited for instructions before taking action. They followed established procedures without question and were discouraged from suggesting modifications. They worked under intensive supervision that assumed potential incompetence rather than potential contribution. American production achieved excellence through worker engagement, while German production pursued excellence through worker compliance. The American approach scaled indefinitely as production expanded. The German approach reached natural limits as supervision requirements increased. As Allied forces approached the prisoner camp, Hartmann's final words to his fellow prisoners captured the complete transformation in German understanding of industrial capability. We believed German precision represented the pinnacle of manufacturing achievement. We discovered that American systematization had transcended traditional limitations. They did not defeat us through superior workers or superior machines. They defeated us through superior systems that made ordinary workers and standard machines perform extraordinarily. We lost not just a war, but an entire era of industrial thinking. The ultimate vindication of American industrial philosophy came on April 30th, 1945, as Adolf Hitler's bunker fell silent beneath Berlin and the Reich that had promised to last 1,000 years collapsed after 12. In the smoking ruins of German industry, scattered engineers and technicians began the painful process of comprehending how completely American manufacturing methods had rendered German production obsolete. The story of this industrial transformation would be written not in victory parades or surrender ceremonies, but in the quiet testimonies of German workers who had witnessed the future of manufacturing and recognized that their nation's approach belonged to an obsolete past. Among the final witnesses to this industrial revolution was Dr. Werner von Braun, the rocket engineer whose V-2 weapons had represented the pinnacle of German technological achievement. As American forces surrounded his research facility at Peenemünde, von Braun reflected on intelligence reports that revealed American production capabilities exceeding anything German science had thought possible. The Americans were not just winning through superior numbers, they were demonstrating manufacturing principles that would reshape global industry for generations. Braun had received detailed reports from German engineers who had been captured and employed in American aircraft factories. Their testimonies painted a consistent picture of production methods that achieved results German engineering had considered theoretically impossible. American factories were producing complex aircraft using assembly techniques that eliminated the skilled craftsmanship German production required while achieving superior quality and unprecedented speed. The Americans had solved the fundamental problem of complex manufacturing through systematic engineering that made complexity invisible rather than manageable. Where German rocket production required master craftsmen to hand-fit components with precision measured in fractions of millimeters, American aircraft production used interchangeable components manufactured to tolerances so exact that fitting became unnecessary. Von Braun's rocket program had represented the ultimate expression of German manufacturing philosophy, pursuing perfection through precision craftsmanship backed by advanced engineering. Each V-2 rocket required months of careful assembly by skilled technicians who adjusted and fitted thousands of components individually. The process produced weapons of unmatched sophistication that demonstrated German technological superiority while consuming resources that could have equipped entire divisions. American production had taken the opposite approach, achieving adequacy through systematization that enabled mass manufacture of weapons available in numbers that rendered individual superiority meaningless. American bombers might not possess the individual technical excellence of German rockets, but they were available in quantities that could overwhelm any defense. While their production continued to accelerate, the philosophical difference extended beyond manufacturing methods to fundamental assumptions about industrial warfare. German production pursued technological superiority through advanced engineering and precision manufacturing. American production pursued strategic dominance through systematic manufacturing and overwhelming quantity. In total war, strategic dominance defeated technological superiority because wars were won by available weapons rather than perfect weapons. The Americans had understood this principle and designed their entire industrial system to maximize availability rather than individual performance. Von Braun's final assessment, recorded in documents later captured by American intelligence, acknowledged the complete failure of German industrial philosophy when confronted with American systematic production. We believed that German engineering excellence and manufacturing precision would triumph over American industrial capacity. We discovered that American systematization had transcended traditional manufacturing limitations. They achieved superiority not through better engineering, but through better systems that made engineering excellence routine rather than exceptional. The industrial transformation that German prisoners had witnessed represented more than wartime mobilization. It represented evolutionary advancement in manufacturing capability that would dominate global production for decades. American methods could be replicated, scaled, and improved indefinitely. German methods required specialized facilities, skilled workers, and cultural traditions that could not be easily transferred or expanded. As German prisoners prepared for repatriation, many requested permission to remain in America to continue working in the factories where they had discovered manufacturing methods superior to anything their homeland could offer. Their requests revealed the complete psychological transformation that exposure to American production had created among German technical personnel. These men had arrived in America as confident representatives of the world's most advanced industrial nation. They had expected to find primitive manufacturing methods that confirmed Nazi propaganda about American industrial weakness. Instead, they had discovered production systems that exceeded German capabilities across every measure of manufacturing excellence. Their testimonies, compiled in intelligence reports that would remain classified for decades, documented the systematic destruction of German industrial confidence through direct exposure to American manufacturing superiority. The Americans had won not just through superior resources, but through superior methods that rendered German approaches obsolete. The prisoners' requests to remain in America represented more than individual preference. They represented recognition that American industrial methods offered opportunities for advancement that German traditions could not match. The democratic approach to manufacturing that encouraged worker innovation and rewarded improvement. Suggestions provided career possibilities that German hierarchical systems prevented. American factories treated skilled workers as valuable assets whose knowledge and experience could contribute to continuous improvement. German factories treated skilled workers as disciplined executors of engineering decisions whose role was implementation rather than innovation. The difference in treatment reflected deeper philosophical differences about human capability and industrial organization. American management assumed that workers possessed intelligence and creativity that could enhance production efficiency. German management assumed that workers required detailed supervision and precise instruction to maintain quality and productivity. These assumptions became self-fulfilling prophecies that shaped industrial performance. American workers contributed innovations that continuously improved manufacturing efficiency. German workers followed established procedures that maintained predetermined performance levels without significant improvement. As Allied forces established occupation governments throughout defeated Germany, American industrial advisors discovered the full extent of German manufacturing limitations that prisoner testimonies had revealed. German factories were specialized for military production and could not easily convert to civilian manufacturing. German equipment was optimized for current products and could not readily adapt to different requirements. American factories could transition seamlessly between military and civilian production because their systematic methods were product-independent. American equipment was designed for flexibility and could manufacture different products through tooling changes rather than equipment replacement. The industrial foundation that would enable Germany's post-war economic recovery would be built using American methods implemented by German workers who had learned superior manufacturing techniques in American factories. The prisoners who had witnessed American production superiority would become the teachers who transmitted advanced manufacturing knowledge to their defeated homeland. Their transformation from confident representatives of German industrial excellence to humble students of American manufacturing methods symbolize the complete reversal of global industrial leadership that World War II had accomplished. The industrial epilogue to World War II was written not in the signing ceremonies at Reims or aboard the USS Missouri, but in the quiet conversations between German prisoners and American factory supervisors as the greatest conflict in human history drew to its close. On May 8, 1945, as victory in Europe was declared across the Allied world, thousands of German technical personnel who had witnessed American production methods firsthand faced a profound personal and professional reckoning that would reshape their understanding of industrial capability forever. Among these witnesses was Meister Johann Kruger, the master machinist from Henschel who had spent 3 years observing American tank production at the Chrysler Arsenal. As he prepared for repatriation to a Germany that existed now only in ruins, Kruger composed a detailed technical report that would serve as his final testimony to the industrial revolution he had experienced. His words, preserved in American archives, captured the complete transformation of German technical consciousness that exposure to American methods had produced. I came to America believing that German precision and craftsmanship represented the pinnacle of manufacturing achievement, Kruger wrote in his careful script. I returned to Germany knowing that American systematization has rendered traditional manufacturing methods obsolete. We were not defeated by superior materials or superior workers. We were defeated by superior thinking about how industrial production should be organized and executed. Kruger's report detailed the systematic advantages that American production had demonstrated across every aspect of manufacturing. Where German factories pursued excellence through individual craftsmanship, compensating for system limitations, American factories achieved excellence through systematic capability that eliminated the need for individual compensation. Where German production emphasized detection and correction of problems after they occurred, American production emphasized prevention of problems through design that made errors impossible. The Americans had industrialized quality itself, creating mechanical and organizational systems that achieved consistency automatically, rather than through human vigilance. They had democratized precision, making accuracy available through systematic methods rather than individual skill. They had systematized innovation, creating organizational cultures that improved continuously rather than occasionally. These achievements represented more than technical advancement. They represented philosophical evolution in understanding how human intelligence and mechanical capability could be combined to transcend traditional manufacturing limitations. American production had solved problems that German engineering had not recognized as solvable and achieved capabilities that German industry had considered theoretically impossible. Kruger's analysis extended beyond manufacturing techniques to the cultural foundations that enabled American industrial superiority. American workers were treated as thinking participants in production processes rather than mechanical executors of predetermined procedures. They were encouraged to contribute ideas for improvement and were rewarded for innovations that enhanced efficiency or quality. German workers were expected to follow established procedures without question or modification. They were discouraged from suggesting changes and were rarely consulted about production problems. This hierarchical approach to manufacturing organization limited German production to predetermined efficiency levels, while American democratic approaches enabled continuous improvement that exceeded original design. Specifications. The cultural differences produced practical results that validated American assumptions about worker capability and industrial organization. American factories achieved higher productivity through worker engagement rather than worker compliance. American quality improved through worker initiative rather than supervisory control. American innovation emerged from production floors rather than engineering departments exclusively. As Kruger prepared to return to Germany, he recognized that the industrial knowledge he had acquired in America would be essential for his nation's reconstruction. The manufacturing methods he had learned represented advancement beyond traditional German approaches that would be necessary for competing in post-war global markets. American production methods were not merely superior techniques that could be adopted selectively. They represented integrated systems that required comprehensive implementation to achieve full effectiveness. The precision manufacturing, systematic quality control, and democratic organization that characterized American factories were interdependent elements that reinforced each other to produce superior results. German reconstruction would require more than rebuilding destroyed facilities. It would require fundamental transformation of industrial philosophy and manufacturing culture. The hierarchical approaches that had characterized German production would need to evolve toward democratic methods that engaged worker intelligence and initiative. The precision craftsmanship that had been German industry's greatest strength would need to be supplemented by systematic standardization that enabled mass production at quality levels that individual craftsmanship could not sustain across large volumes. Kruger's final assessment acknowledged the complete reversal of global industrial leadership that the war had accomplished. Germany began this conflict as the world's most advanced industrial nation, confident in our technological superiority and manufacturing excellence. We end this conflict having discovered that American methods have transcended every limitation that constrained traditional manufacturing. They have shown us the future of industrial production, and we must learn from them or remain forever in the past. Similar testimonies from thousands of German technical personnel who had worked in American factories created a comprehensive record of industrial transformation that would influence global manufacturing for generations. These men had witnessed the birth of modern production methods that would spread throughout the world as American companies expanded internationally, and American techniques were adopted by foreign manufacturers. Defied, democratic manufacturing principles, systematic quality control, and precision standardization that German prisoners had observed in American factories would become the foundation of post-war industrial development worldwide. The methods that had enabled American victory in World War II would enable American dominance in global markets for decades. The German prisoners, who had experienced this industrial revolution firsthand, would become ambassadors of American manufacturing methods when they returned to their homeland. Their knowledge would be instrumental in rebuilding German industry, using advanced techniques that exceeded pre-war German capabilities. Their transformation from confident representatives of German industrial excellence to humble students of American manufacturing superiority symbolized the broader transformation of global industrial leadership that World War II had accomplished. The war had ended not just with military victory, but with the establishment of American industrial methods as the new standard for manufacturing excellence worldwide. The industrial legacy that would define the post-war world crystallized in the months following Germany's surrender as American occupation authorities began the complex task of rebuilding German industry using the very production methods that German prisoners had witnessed and reported with such devastating accuracy. By August 1945, as the atomic bombs fell on Hiroshima and Nagasaki, demonstrating American technological supremacy in the most dramatic fashion possible, a quieter but equally significant transformation was already underway in the bombed-out factories of the former Reich. Irony was not lost on German engineers who found themselves learning American manufacturing techniques from their former prisoners of war. Men like Oberingenieur Klaus Brenner, who had initially dismissed prisoner testimonies about American production capabilities, now sat in makeshift classrooms listening to detailed explanations of systematic manufacturing from German technical personnel who had mastered these methods in American factories. The re-education process revealed the true scope of the Industrial Revolution that German prisoners had experienced. American production methods were not simply superior techniques that could be grafted onto existing German practices. They represented a completely integrated approach to manufacturing that required fundamental changes in thinking about industrial organization, worker relationships, and quality control. Brenner's first lesson came from his former subordinate, Meister Wilhelm Hartmann, who had returned from the Ford Rouge complex with knowledge that exceeded anything Brenner had learned in decades of German engineering experience. Hartmann's explanation of American systematic manufacturing challenged every assumption about industrial production that Brenner's career had reinforced. Herr Oberingenieur, Hartmann began with the patience of a teacher addressing a struggling student. American production succeeds because it eliminates the need for the skilled intervention that our methods require. They have created systems that achieve precision automatically rather than manually, quality consistently rather than occasionally, and improvement continuously rather than sporadically. The demonstration that followed shattered Brenner's remaining confidence in German manufacturing superiority. Using improvised equipment and salvaged materials, Hartmann reproduced American assembly, techniques that achieved results exceeding anything the sophisticated Krupp facilities had accomplished at their peak operation, where German methods required individual fitting and adjustment of components. American techniques used interchangeable parts, manufactured to tolerances so precise that assembly became mechanical insertion rather than skilled craftsmanship. Where German production demanded constant supervision and quality inspection, American systems included automatic feedback mechanisms that prevented defects rather than detected them after occurrence. The transformation was not merely technical, but psychological. German industrial culture had emphasized individual excellence, achieved through years of apprenticeship and accumulated experience. American industrial culture emphasized systematic capability that enabled ordinary workers to produce extraordinary results through superior methods and equipment. This philosophical difference had profound implications for post-war reconstruction. German industry could not be rebuilt using traditional approaches because the craftsmen who had provided its foundation were dead, scattered, or demoralized. American methods offered the possibility of achieving superior results using available workers, trained in systematic techniques that did not require lengthy apprenticeship periods. The re-education program that emerged from these initial lessons would transform German manufacturing more completely than decades of gradual evolution could have accomplished. German engineers, technicians, and workers were systematically trained in American production methods by their compatriots who had learned these techniques in American factories. The process created a feedback loop that accelerated German industrial recovery while validating American manufacturing superiority. Every German factory that adopted American methods achieved productivity improvements that exceeded pre-war performance levels. Every German worker who learned systematic techniques became more capable than traditional apprenticeship had made possible. Within 2 years of the war's end, German industrial output was approaching pre-war levels using American methods implemented by German workers who had acquired this knowledge through direct experience or systematic training. The recovery rate exceeded all Allied projections and demonstrated the transformative power of advanced manufacturing techniques. More significantly, the German industrial recovery became a showcase for American production methods that influenced global manufacturing development. International observers who studied German Reconstruction discovered that American techniques could be successfully implemented in different cultural and economic contexts while producing superior results. The success of American methods in Germany encouraged their adoption throughout Europe, Asia, and other regions where industrial development was proceeding. The systematic manufacturing, democratic worker relationships, and continuous improvement principles that German prisoners had witnessed became the foundation of global industrial modernization. The prisoners who had initially been shocked by American production capabilities became the teachers who transmitted this knowledge throughout the post-war world. Their testimonies, initially dismissed as exaggerated or impossible, became textbooks for industrial reconstruction and development. The transformation extended beyond manufacturing techniques to fundamental changes in industrial relationships and organizational culture. The hierarchical management structures that had characterized German industry gave way to more democratic approaches that engaged worker intelligence and initiative. Quality control evolved from post-production inspection to systematic prevention through process design. Innovation shifted from formal research departments to continuous improvement involving all production personnel. Efficiency increased through systematic methods rather than intensive supervision. These changes produced results that validated American assumptions about industrial organization and worker capability. German factories operating according to American principles achieved productivity levels that exceeded their pre-war performance while maintaining quality standards that surpassed traditional German excellence. The industrial victory that American production had achieved during World War II continued in peacetime as American methods spread throughout the global economy. The systematic manufacturing techniques, democratic worker relationships, and continuous improvement principles that had enabled wartime production superiority became the foundation of post-war economic dominance. The German prisoners who had witnessed this industrial revolution had become unwitting agents of American influence, spreading knowledge of superior manufacturing methods throughout the world. Their initial shock and disbelief had evolved into understanding and advocacy that promoted American techniques wherever industrial development was occurring. The war had ended with more than military victory. It had established American industrial methods as the global standard for manufacturing excellence that would influence economic development for generations. The final reckoning of America's industrial triumph over German manufacturing philosophy came not in the factories or boardrooms where the transformation had been witnessed, but in the quiet reflection of those who had lived through both systems and understood what the change truly meant for the future of human civilization. By 1950, 5 years after the war's end, the German prisoners who had returned with tales of American production superiority had become the architects of their nation's industrial resurrection, building new factories that surpassed their pre-war achievements using methods they had learned from their former enemies. In a small apartment in Essen, overlooking the rebuilt Krupp works that now hummed with American-inspired efficiency, Oberingenieur Klaus Brenner sat at his desk composing his memoirs. The man who had once dismissed prisoner testimonies about American production capabilities now served as technical advisor to the German government's industrial reconstruction program, implementing the very methods he had refused to believe possible. The American achievement, Brenner wrote in his careful script, was not simply industrial superiority, it was the democratization of excellence itself. They showed us that systematic thinking could transcend individual capability, that proper organization could multiply human potential, and that industrial democracy could achieve results that hierarchical precision never could. His words reflected a transformation that extended far beyond personal understanding to encompass an entire nation's relationship with industrial production. Germany had entered the war confident in its technological supremacy and manufacturing excellence, certain that precision craftsmanship and engineering sophistication would triumph over American quantity and mass production. Germany emerged from the war having discovered that American methods represented evolutionary advancement in manufacturing thinking that made traditional approaches obsolete. The German prisoners who had witnessed American production firsthand, had become prophets of industrial change. Their testimonies, initially dismissed as impossible but ultimately validated as accurate descriptions of manufacturing methods that transcended traditional limitations. Their knowledge had become the foundation of German reconstruction, enabling recovery rates that exceeded all projections while establishing new standards of industrial capability. The transformation was complete and irreversible. German factories now operated according to American principles of systematic manufacturing, democratic worker engagement, and continuous improvement. The precision craftsmanship that had been German industry's greatest pride had been supplemented by standardization that enabled mass production at quality levels individual skill could never sustain across large volumes. Workers, who had once required years of apprenticeship to develop, manufacturing competence now achieved superior results through training programs lasting weeks or months. The systematic methods that American prisoners had described with such precision had eliminated the skill barriers that had limited German production, while creating opportunities for advancement. The traditional approaches had prevented quality control had evolved from post-production inspection to systematic prevention through process design that made defects impossible rather than detectable. Innovation had shifted from formal engineering departments to continuous improvement involving all production personnel. Efficiency had increased through systematic methods rather than intensive supervision or longer working hours. The results validated every claim that German prisoners had made about American manufacturing superiority. Factories operating according to American principles achieved productivity levels that exceeded pre-war German performance while maintaining quality standards that surpassed traditional German excellence. The systematic approach to manufacturing had proven superior to traditional methods across every measure of industrial capability. More significantly, the American methods had proven transferable across cultural and economic boundaries. The techniques that had enabled wartime production superiority were successfully implemented in different national contexts, while producing similar improvements in industrial performance. The systematic manufacturing principles were universal rather than uniquely American. This universality had profound implications for global economic development. The methods that had enabled American victory in World War II became the foundation of post-war prosperity as they spread throughout the international economy. Countries that adopted American manufacturing techniques achieved industrial advancement that exceeded their historical performance, while nations that resisted these methods fell behind in global competition. The German prisoners, who had initially been shocked by American production capabilities, had become the teachers who transmitted this knowledge throughout the post-war world. Their testimonies, once dismissed as exaggerated or impossible, had become textbooks for industrial modernization. Their transformation from confident representatives of German industrial excellence to humble students of American manufacturing superiority had become the template for global industrial development. The war had ended with more than military victory. It had established American industrial philosophy as the dominant approach to manufacturing that would influence economic development for generations. The systematic methods, democratic worker relationships, and continuous improvement principles that German prisoners had witnessed became the standard practices of modern industry worldwide. As Brenner concluded his memoirs, he reflected on the broader implications of the industrial transformation he had witnessed and helped implement. The American achievement represented more than superior production techniques. It represented advancement in human understanding of how industrial organization could multiply individual capability and democratize excellence. We believed, Brenner wrote in his final assessment, that German precision and craftsmanship represented the pinnacle of industrial achievement. We discovered that American systematization had transcended traditional manufacturing limitations through methods that made excellence routine rather than exceptional. They did not defeat us through superior materials or superior workers. They defeated us through superior thinking about how human, intelligence, and mechanical capability could be combined to achieve results that individual skill alone could never accomplish. The prisoners' shock at American production capabilities had evolved into understanding and advocacy that promoted superior manufacturing methods wherever industrial development was occurring. Their initial disbelief had become conviction that systematic approaches to manufacturing represented evolutionary advancement that would define industrial progress for decades. The transformation was complete. German workers who had once been prisoners in American factories had become the masters of rebuilt German industry that exceeded its pre-war achievements. The methods they had learned from their captors had become the foundation of their nation's recovery and the template for global industrial development. The war had ended not just with military victory, but with the establishment of American industrial methods as the new standard for manufacturing excellence worldwide. The shocked testimonies of German prisoners had become the foundation of industrial transformation that would reshape the global economy and establish American leadership in manufacturing that would persist for generations.